Basic Metaphysics, a lecture by Jonathan Barlow Gee. Part 1. The Torus. To understand the shape and properties of four-space manifolds, we begin with an examination of this familiar diagram displaying the standard elliptical orbit of a body in space around a dual focal point. The labels are as follows, clockwise from left to right. The sphere in orbit is labeled D. The orbit itself is labeled M. And the dual focal points are labeled ST and TS. The meanings of these labels is adumbrated on at length in my book, The Metaphysician's Desk Reference. However, their significance to this model is unimportant here, considering only the form of the model itself. The next form of this model shows us the orbital plane from along the edge, from which vantage we may see a further twist in the shape of the orbit, such that it resembles a sideways figure 8, the symbol of infinity. Here the labels remain the same as before. D signifies now two positions of the orb in its orbit around the dual foci, labeled here also ST and TS. The twisting orbit is labeled M. In this form of the model we may see that, due to the optical illusion formed by looking at the usual elliptical loop from along the edge, 2 points on opposite sides of the ellipse appear to converge in the center between the twin focal points. In the third iteration of this model, we symbolize this superposition of opposite points on the original ellipse by inserting a third position for D, the orbiting sphere. The label and shape of the orbit M remains a sideways figure 8. However, now we see that this superposition point of illusory intersection can be symbolized by a third position of D, the body in space, that actually signifies two foreshortened and visually overlapping points in the elliptical orbit M from the original diagram. Thus, we may now also see that this third superposition point for D along M has an equator co-circumferential to the circle originally signifying the dual focal points, such that this superimposed midpoint position for D sits within the center between the focal points ST and TS. In this next form of the original model, we further elaborate on the superposition midpoint of the orbiting sphere, D, by proportioning upon it the usual depiction for the effect on its poles of precession, labeled P. The semblance of this addition shows that an upward pointed cone tapers asymptotically in an arced surface from a circular base below the midpoint of D, the orb, while another identical cone points downward from above, such that the tips of the two arced cones intersect in the center of the midpoint of D. In this form of the model, we may see the co-circumferential equatorial circle signifying the conical angle of the orb D's polar precession are perpendicular on the left and right sides of the twisted figure 8 orbital ellipse M, to the position of them relative to the central overlapping position of the sphere D in its orbit. In short, we see the midpoint position of D operates at a right angle to the orientation of D on the left and right. Thus, as I am attempted to prove in my book, the MPDR, the orbit of the precessing poles of D forms the exterior, and the sideways figure 8 angle of the ellipse form the interior of a standard four-space torus. What we are seeing in this final form of the original model is 1/2 of a torus. In this complete model of a torus, we see the manner the four-space torus evolves from one-space singularity. First, the point expands into a line, shown here operating at a right angle along a vertical axis in purple. This line is then rotated at this angle around its singularity origin point to form a plane, which is shown as the red spiral in the middle, signifying polar precession. This red spiral line traces the plane space surface of the line's rotation around its midpoint as a wavelength, shown in yellow, signifying the equator of the torus. The red spiral line on this plane surface also rotates around itself, and this is shown expanded as the blue spirals on the left and right connected around the toroid equator as a green coil. This gives us all the motions that a point on a torus can move along. The essential concept of the torus is that it is a four-space expansion of the one-space singularity in four directions. The resulting shape is essentially as appears here and is called a torus or hypersphere. The usual nomenclature distinction between these terms is that a torus is a hypersphere seen from along its equatorial side, while a hypersphere is a torus seen from above its polar axis. In this diagram, again from my book, The MPDR, we may see that a toroid equator surrounds the nested hypersphere. The concept of the torus or hypersphere is that it is a sphere within a sphere, where both spheres have the same volume, symbolizing a single sphere moving in the invisible direction of time. The torus, as we see here from above one pole on the left and from above the opposite pole on the right, obeys the laws of wave mechanics and in turn determines the wavelength motion of spherical particles. We see the three directions of possible motion that a point on a torus can travel in as a large blue arrow around the toroid's exterior circumference, as a series of small green arrows signifying particle rotation inside the toroid, either in the inner or outer hypersphere, and as a red wavelength measuring a spiral line drawn along the plane surface of the toroid equator. To return to the complete toroid form of the original model from the MPDR, we see the combination of the motions within the inner sphere and upon the exterior sphere cause the polar precession of a point as it moves along all these possible directions over time. As a point moves along an elliptical orbit, the poles of the point precess such that over time they reverse orientation, first at a right angle, then to 180 degrees opposite from their original orientation, and finally back again. This perpetual cycle forms the overall model of a four-space torus from the side, or hypersphere from above. Because this depiction itself is flat, we may see it as a shadow of this higher dimensional shape cast onto a 2D plane space. Because a torus is 4D, it also casts a 3D shadow. The shadow of the hypersphere is the simple 3D orb, but the shadow of the torus, a hypersphere seen from the side, is shaped like a circularly self-connected tube. This tube has a circular circumference. However, if you were to trace the motion of a single point on the exterior surface of the toroid circumference, you would follow it as it formed a phi spiral. If you were to take the phi spiral formed on the exterior surface of a torus as it revolves inward on itself and combine it with the pi spiral motion of a point on the interior of the torus as it revolves around in a circular tube, the result would be this diagram showing the shadows of these two types of spiral, the exponential phi and the arithmetic pi, on a flat plane space with their twin origin points exactly overlapped. The significance of combining these two spirals as flat shadows in this way is to depict the point where the interior of the torus becomes the exterior of the torus as a parameter where both spirals inner pi and outer phi, coincide. For shorthand, I refer to this pair of spirals throughout all my writings on metaphysics as a single phi over pi spiral. When we double such an already combined phi over pi spiral with an exact duplicate of itself in mere reflection, by overlapping both centroids onto a single origin point, we arrive at this depiction, which is best thought of as a shadow cast by the motions of a point on a hypersphere seen from above or below one of its poles. When we double the phi over pi spirals at a point along their axis line, but not exactly overlapping one another on a conjoined origin point, we arrive at this model, best seen as a shadow depiction of point motion along the toroid edge or the hypersphere seen from the side. If we flatten the motion of a point on a torus surface into a plane, the result is this autocorrelated mapping, the so-called 7-color coding pattern of the surface of a torus. When the space labeled 1 is connected to the space labeled 7, inside a coil formed by the spaces between 1 through 7, we see yet another form of the torus, or hypersphere, seen from along its equator. This 7-color coding maps onto the surface of the round tube torus such that it forms the phi spiral upon it.